All right, hello and welcome. Hope you all had a good weekend. Just a reminder, hopefully you're already aware of this, the first homework assignment is due 2 weeks from today. I know some of you have already gotten this start on it. I've talked to you about it. That's great. That's fantastic. I would encourage you to please get started on this sooner rather than later. We've got TAs with lots of office hours, I think almost every day of the week. Not quite, but almost. If you have questions on that. And then as we discussed last week in class, I shipped out some unit tests for you for this homework assignment. So the instructions on how to gain access to those unit tests are on Piazza in a post that I made last week. So hopefully you've already done that. If not, you can go do it whenever you've got a spare moment. And just to be super 100% clear, I am going to use those unit tests in terms of grading. So what that means effectively is that you guys are writing the tests to grade your own assignments. So, and that's going to be the theme this whole semester, actually. I think that's all the announcements that I have. Are there any questions? I'd be happy to answer questions about homework 1, whether that's logistical stuff or even conceptual stuff. If you're stuck on part of homework 1, happy to take a few moments to talk about that now. Yeah.
So for grading, as long as we pass all the tests you gave us, is that good?
So I want to be a little bit careful. The tests are definitely a large part of the grading. However, there have been instances where people will hard code in answers to the tests and things like that. So I'm not going to say that if you pass all the tests, you're going to get a perfect score. We are still going to inspect your code. We're going to make sure that you don't have things hard coded in places just to pass the test, things like that, right? So if you honestly pass the tests and you're not trying to trick us, then yes, you will get a good grade on the assignment.
So there won't be tests that you hide from.
That's correct. Yes, there are no tests. I'm being transparent with you guys. I mean, it's not even me being transparent with you. You are the ones who wrote the tests, right? You guys are the ones who are steering. I know that I'm kind of putting my finger on the scales a little bit, right? Giving you a push in the right direction. But as time goes on, just to give you a little sneak peek in the future, right? As time goes on, I'm going to start backing off even more, and you guys are going to have a lot more control over what these tests do and how the homework assignments are graded. So, yeah.
Will there at least always be some bare minimum tests you give us for helping us knowing that we're doing right? Like, we're never going to have to write all the tests for our assignment. Then
actually, as we get to the end of the semester for the last homework assignment in particular, I have been known to give you carte blanche on writing unit tests for your own assignment, but that is a ways away. We've got a lot of time between now and then, and my goal is between now and then to spend more time talking about what makes good unit tests, write a lot more unit tests so that you'll be a lot better at it at that point in time, and it hopefully won't be as much of a big scary thing as it might be now. But that is my goal, right, is to get you guys to be more independent with writing those tests, testing your own code. So I'm working towards that for sure. But for the next few assignments, I'll provide you some small examples. We'll do some examples in class, etc. Any other questions? Yeah.
Have the unit test grades been updated anywhere?
I'm sorry?
The grade for the unit.
Nope. So the 5 bonus points have not been updated. Nope. That was pretty low priority for me, honestly. I was trying to get the unit tests out the door. So that is on my to-do list for this week. And just looking at my schedule, I can say probably Wednesday is the soonest I'm going to be getting to that. So it is on my to-do list, but not extremely high on my to-do list at the moment. So I'll post a thing on Piazza whenever I get it processed. Cool. Any other questions? Yeah.
We didn't grade on how well our code is, how nice it is,
how
like your code, like how nice our code.
How nice it is. So style-wise, or I mean, so formatting style-wise, I'm not going to be too picky as long as your code isn't a complete dumpster fire. Then we're probably okay, right? I understand that code is often not pretty, especially the first time you get through it. I do think it's good to write clean code, and that is actually another soapbox that I could stand on, but one that I'm not going to stand on in this class anyway. I got some other things in the works for that. But as far as this class goes, you know, as long as I can read your code and understand what's happening, that's kind of the bar, right? Don't show your code to somebody else. Show your code to me, and if I say, yeah, I can understand that, then you're good. For a TA. Any other questions about the homework assignments? You haven't talked about conceptual stuff too. If you guys, anybody started on it, needs a push in the right direction, be happy to chat about it. No? All right. We good? Cool. All right. Then let's get to today's topic at hand. Today we're going to be talking about designing and implementing a database. And so we're already kind of shifting gears a little bit here. The first couple weeks of class, we've been focused very much on low-level stuff, physical implementation, physical representation of our data on disk. And that stuff is still important to us, right? It still matters because it does influence the high-level design and implementation of our database as well. But we're already kind of starting to move away from that, move farther up, make things more high-level. So just kind of a quick blueprint for the next couple of weeks here as we progress towards homework assignment number 2, right? We're gonna start really focusing in on queries and how to implement queries on our database. That is where we're headed. Now, there's a couple things that we need to lay the groundwork for before we can get there. So this week's a lot of laying groundwork. This week is actually going to be a fair amount of theoretical stuff, which I know is maybe not what you all signed up for when you registered for this class, but it's important that we understand that theoretical background so that when we get to the implementation stuff next week, we have a good foundation to understand how all that stuff is going to work. So today we're going to talk about creating, designing, and implementing a database. It's a fairly SQL-y heavy day if that's your thing. And if not, well, we'll do something different on Wednesday. So let me go ahead and get this up here on the screen. So in terms of designing our database, now when I say designing our database, what I'm really talking about are, you know, what tables are going to exist, what columns are going to exist, right? Those are the kinds of things that I'm talking about. Not necessarily the database management system. That's our ultimate goal, right? But in order to understand how to design an effective database management system, we need to understand how people are going to use our database appropriately. So I'm talking here strictly from a tables, rows, and columns perspective, right? What kinds of things should be in a database? There are very long-lasting implications of this because any of you who have worked with databases are probably already somewhat familiar with the idea that once you've created a table or a set of tables, it can be very difficult to modify those tables, the definition. It can be very difficult to modify what columns exist in those tables. It's usually pretty easy to add things, add new tables, add new columns. That's usually not too bad, but changing something that already exists, especially if you've already got millions of rows in that table, can be a tricky thing to do. So it's very important to spend some time thinking about our design, doing the design first on paper, or in our case today, the chalkboard, getting some stuff down so that we know exactly what we're doing when we create our database. So quick refresher, how's our data being stored again? We know it's in tables and columns, but ultimately those tables and columns are files, binary files, right? Binary files. So that's important for us to keep in mind as we think about how we're designing our tables, our rows and columns that are going to sit on top of those files, right? It's important for us to keep in mind. And then how do we manipulate data? So we've already talked about this a little bit during the first week of class. We manipulate data by writing queries, SQL code. And so that's another very important thing for us to consider as we think about what tables need to be included in our database. I'm going to have to write queries that act on those tables. So I want my tables to be set up in such a way to make writing those queries simple and straightforward so that I'm not writing queries that are 10 pages long, right? Hopefully. That's the goal. So we're going to do an example today. We're going to design a database together as a class and come up with a design up here on the chalkboard. And here's our pretty classic example of a design that we want to implement. We have a company that's organized into various departments, and every department is going to have name, department number associated with it, and some employees that belong to that department, right? Our departments might be in several different locations. So think about, Facebook's got offices all over the place, right? Google's got offices all over the place. So it may not be in just one spot. It might be in many different spots. Every department's going to have a certain number of projects associated with it. So a project is going to have, a name associated with it, a number associated with it, and the location where that project's being worked on. And then as far as employees go, right? Employees work for departments. They also work on projects. So they kind of tie everything together. And we want to track some information about our employees, things like their name, their address, how much money they get paid, things like that. And then as you get older, you'll realize the value of having good health insurance plans for your dependents. So we want to track some information about that as well. How many, it doesn't have to be kids, but a lot of times it's your kids or other people who are dependent on you. What's their relationship to the employee, right? How old are they, et cetera, et cetera, et cetera. This is pretty standard stuff. If you've ever had an internship or maybe even a job out in industry, right? This is pretty standard stuff. There's nothing in here that's intended to be complicated. What I want to do now is analyze this example and think about, if I wanted to make a database to track all of this information, what would that database look like? And so there's a kind of a step-by-step process for doing this, and we're going to go through those steps now. So step number one is to define our entities and attributes. And so an entity is, you can think of an entity as being a big concept, a major concept, and an attribute being a piece of an entity, something that helps us describe what an entity is. We talked about this again in the first week or so of class, right? It feels very similar to designing an object in Java or some other object-oriented programming language, right? There's kind of a relationship there. And so to help you, figure out what your entities might be, a good tip, a good rule of thumb is if you have your spec sheet in front of you, like we do here, look for words that are repeating themselves many, many times, right? That's not a guarantee that it's going to be an entity, but it's at least a place to start looking. So what are some things that we feel like might be entities in this particular example? Employee. All right, so I'm going to start making a diagram up here. And I'm going to start by simply writing down the entities that we come up with. And for the sake of our diagram, entities are typically circled. Okay. What's another entity? Yeah, go ahead. Name. So if I think about a name, is that a big defining topic part of my database, or is that something that's used to help me define other parts of my database? Does that make sense? Maybe that was a bad, poorly worded question. So like department is a good entity, I believe. And I could see why you would say name, because one of the first things I said is look for words that repeat themselves a lot, and name repeats itself a lot on this slide, right? But we have to be a little bit more careful about that. Name, I think, especially if we look at department or employee, it appears for employees as well, describes an employee, it describes a department. If I just look at a name by itself, I'm not always sure what that name is referring to. It needs the additional context, right? Oh, this is the name of a person, this is the name of a dog, I don't know, right? It needs additional context to go along with it. So department I like as an entity. What other entities do we have? There's at least a couple more. Yeah. Location. All right. I'm going to try and be careful about where I put these. Location. Okay. Any others? Project. I think there's one more. Dependent. I don't have a ton of room, so I'm going to squeeze it over here, I guess. By the way, slightly off-topic tangent thing to mention. I am recording right now, but I'm not recording this. So thank you for coming to class today. You guys get to copy this diagram down into your notes. If you're watching this on YouTube, hi, come to class. We do lots of cool stuff, sometimes on the board, so come to class. But seriously, come see me in office hours, come see a TA, and we'll be happy to go through this example with you if that's something that you need. All right, so we've got our entities down. We also need to think about attributes. Attributes, so the things that describe these entities. So if we start with employee, right? I think the way that the description is written makes this pretty straightforward. I see there's an employee number, name, address, salary. So the way I'm going to incorporate these on my diagram is just draw little bubbles coming off of the entity bubbles, right? So name. Now address is kind of an interesting one. I can't even, no, I spelled it right. Address is kind of an interesting one, right? Because address is a long chunk of stuff. And so the question that I have for you is, if you're looking at a database or any piece of data, right? Would you rather have address stored as one big giant chunk of stuff? Or would you rather have address stored as the different pieces within? Does anybody have an opinion on that?
Different pieces, because you might use like country for location and state in the location table. Whereas the address would be like street name, state, country, zip.
Yeah, so depending on how our address is formatted, right, that can make it very difficult to interpret. If I have lots of international addresses mixed together and I try to go through and parse those, right, it's going to make my life a lot more difficult. But if I have it broken down in smaller pieces, it makes it easier for me to find what I'm looking for, right? Or another way of thinking about it is on the computer, right? Is it easier to take something and split it into chunks, or to take something that's in small chunks and stitch it back together again? It's usually a lot easier to take something that's in small chunks and stitch it back together again, right, if I need it. And so address is a classic example of what we call a composite attribute, right? Address itself is an attribute, but what do we really care about as far as the database is concerned, as far as storing that information? We care about the individual pieces of it. So the pieces being street, right? City, state, right? Zip code. I don't have space to put all the different pieces up there, but you guys hopefully get the idea what I was going for. It's a composite. There's a hierarchy, right? There's a hierarchy. What else did I have for employee? I had an employee number. All right. Okay. And so we do this with all of our entities, and I don't know that we need to do this for all 5 of the entities that are up here on the board, but we can do it for at least, a couple more. Location's a little tricky, right? Maybe. Location's a little bit tricky. I don't see a list of attributes listed for a location, right? Like I do for the other ones. Yeah.
Salary also.
Yeah, salary would be here. These boards are, I don't know, is the board small or is my handwriting big? I don't know. A little of both maybe. Having trouble squeezing everything in. But yeah. And so for location, right, there's no actual attributes listed here for location, but address is probably part of it. That's what we typically need to define a location, right? There may not be much else to it. Or if I look at department, for example, I've got a department number and a name. Number and a name. And then you also see employees listed under department, right? But wait a second, I've got employees over here. So do I need an employee column over here too?
Employee limit, employee, is that like a count of the employees?
Is that like a count of the employees? So think about what an entity actually represents. It's a good question. So what does an entity actually represent? Every row is an instance of that entity. So I could have some kind of account here, right, where every row is an department, and this could represent a total number of employees. The downside of maybe doing it that way is that number is going to change, perhaps rapidly, even depending on what industry you're in or what kind of company you're running. Doesn't make it impossible by any means, but just something that we need to keep in mind, and a question that we run into with databases a lot, right? Is this something that I need to actually store, or is this something that's going to be easier for me to just compute on the fly, right? Can I just count my employees when I need to know that number instead of storing that value in the database? It's a classic database question. Sometimes it's going to be faster to just compute it on the fly, especially if the number is changing rapidly. If it's pretty stable, then it might be faster to just store it in the database. So yeah, like most design activities, there's not a right way and a wrong way to do it, right? You have to look at your own needs. You have to look at the actual situation that you're dealing with, which is difficult with a hypothetical situation, I know. You have to look at the actual situation that you're dealing with and make these decisions based on what's in front of you. In terms of actually referring to this employee entity, though, that is something that we need to take into account, but I want to caution you that's not an attribute. It's not an attribute that we're worried about necessarily, linking employees up to departments. That's a further step in the design process for us. And so projects got a name and a number. This is the last one. I won't do all of them. Number. Project also had a location, right? But I'm not going to include a location attribute here. Later on, we'll talk about how I'm going to link up different entities together. Okay? So step one is basically done, more or less. We've defined what entities exist. We've defined the attributes for our entities. In a real-world example, I would expect probably a lot more attributes than this, but this is just meant to be a simple design exercise. Our next task is to define what our key attributes might be. And so key attributes are values that have to be unique for a particular entity. They have to be unique. So looking at the entities that we've got up here on the board, right, and the attributes that we've got listed, if I look at employee, for example, of the attributes listed for an employee, which of them would I expect have to be unique? Number. Any of the other ones? Probably not, right? Probably not. So in order to indicate that, I'm going to underline this. If there was an additional one for employee that could be considered unique, I'd underline that as well. I would underline that too. Okay? And then as far as department goes, it's a similar story, I think, right? I might expect name to be unique for departments because I don't expect a company to have two, marketing departments, for example, right? That's not something that I expect. So I think number is a pretty safe bet. Name, I think you can make an argument for too, right? I think you can make an argument that name can be unique. I do think that there are other situations where maybe that's not a safe assumption to make, and it really depends on the context of what company you're dealing with, right? It really, you just got to look at what's in front of you. So, whether that's underlined or not, it's kind of up to whoever's designing this database for a particular company. Same thing for projects, right? Same thing for projects. Project number, I would reasonably expect to be unique, but project name, could be unique, but I might have projects that are recurring. The same project's going to show up every year, right? In which case the name wouldn't necessarily be unique. So does that apply to our company or not? I don't know. It depends. Take a look at what's in front of you. Be careful with this step. I know I made it seem kind of almost trivially easy in this example because there happened to be an attribute called number for each one of these entities, right? In the real world, that may not be the case. You may be looking at an entity where you don't see anything that seems to be unique for a given entity. And that can be a problem. Why do we care about key attributes? Why do we care about unique values? What is this ultimately going to become for us? These unique attributes. Primary keys. They're ultimately going to become primary keys. We haven't quite gotten to that step yet, right? But they're ultimately going to become primary keys. So if I look at an entity and I don't see any key attributes, that means that I don't currently have any candidates for a primary key, which might seem like a really tough spot, but it's actually not that bad. You can just make one up. You can always just make one up. And we'll see several examples of that throughout the course of the semester. In this case, though, it all worked out nicely for us. There was nice key attributes. While we're on the topic, something else you should pay attention to with key attributes, right, is if I'm designating something as a key attribute, I need to be certain that it's going to uniquely identify each instance of this entity. It can be easy to get fooled sometimes. The classic example of this is a social security number, right? Social security numbers used to be treated as key attributes. When I was going through school, it was fairly standard practice to use social security number as a primary key or as a key attribute for a student or an employee in your database. There's some real problems with that. That's not a standard anymore. That's not something that you should consider doing. Why not? Yeah. So international students don't have social security numbers, or I mean they might have some equivalent, right? But even still, there's problems with that. So there's security issues with that, right? But even above and beyond the security issues is the idea that does a social security number even uniquely identify somebody? Not necessarily. There are 10 digits in a social security number. That's it. There's 10 digits in a social security number. So, they get recycled. Identity theft is a thing. What happens if you have identity theft? Oh, you get a new social security number. Well, there goes your uniqueness, right? There goes your key attribute. It's no longer valid. So it's I guess the point I'm trying to make here is if you're going to make something a key attribute, you need to be absolutely certain that it is in fact going to be unique and always be unique for that given entity. And if you're at all in doubt, if you're all unsure, make one up. Just make one up. Any questions? All right, next step. We've already started doing this. Fantastic. Next step is to talk about relationships. So I've got my entities. I've got my attributes associated with those entities. I think maybe for the sake of cleanliness, I might redraw some of these entities up here so that we can actually see what's going on in this next step. Employees, what do I have? Departments. I'm going to draw without the attributes just to give me some extra space, right? Location. Projects. And dependents. All right, cool. Our next step is to identify relationships that exist between our entities. This is a very, very important step. Why? Why is this so important to identify the relationships that exist between our entities? Anybody who's done work with a database is probably already familiar with what these relationships look like and what they can do for us in our database. We're going to talk about this more on Wednesday as well. Yeah.
They allow us to avoid data duplication.
Data duplication. So that's a big part of it. We're actually going to talk about data duplication coming up very soon, as a matter of fact. But they also protect us against having data incorrectly referenced. We call that referential integrity. We're going to talk a lot about referential integrity on Wednesday. But the short gist of referential integrity is this idea that if I have a dependent, if there's a child in my database, it has to be associated with some employee, right? Like, I love kids, but I'm not taking care of somebody's kids who aren't part of my company. So I need to make sure that the relationship is enforced, right? If I have a dependent here, there's an employee who that dependent belongs to. And so, these things matter, and the database can help us enforce these kinds of relationships so that we don't run into situations where I've got, orphan is a really bad word to use here, but it kind of fits, kind of fits the situation. Orphaned data that doesn't belong to anything. So we talked about this way back in the first day of class, but what kind of relationships exist in a database? There's 3.
1-to-1.
1-to-1,
1-to-many.
1-to-many, and many-to-many. So I don't believe in 1-to-1 relationships. If you do, then okay, I won't argue with you about that. But I do care about 1-to-many and many-to-many relationships, and so I want to take a look at the entities that we have up here on the board and then ask you, right, where do we think the relationships exist? I know, we already talked about this one, right? There's a relationship between dependents and employees, but what kind of relationship is it? What kind of relationship is it? Now, there's really only 2 answers that I would even consider here, 1-to-many or many-to-many. We have to think about what the implications are of those 2 types of relationships, right? It can help to say it in English. So we have to think about not just what kind of relationship it is, but what direction it's going as well. So if I say one employee can have many dependents, that seems like a reasonable thing to say, right? Seems like an okay thing to say. What if I say it backwards? One dependent can have many employees associated with it. Is that a reasonable thing to say? Yeah, what if mom and dad both work for the same company, right? What if mom and dad both work for the same company? So because that relationship worked in both directions, that is an example of a many-to-many relationship. Many-to-many relationship. We would indicate that. There's a couple ways that you can indicate this on our diagram. So we start by drawing a line, right? One notation says you just use n here, n meaning many, right? We use n on both ends of the relationship to indicate that it's many on both sides. If it was a 1-to-many, I would use a 1 instead of an n, right? That's one way that you can represent this relationship on our diagram. Another way you can represent it is to put a fork, right, on the many side. So in this case, we have a fork on both ends since it's a many-to-many relationship. Yeah.
Is there a different way to indicate like and being arbitrary and like it's not like one it's not 1-to-1 but like it's constant like maybe at most 2
So you're talking about a constraint, right? Like if I want to say, okay, an employee can have at most 3 kids under our system, right? You're talking about what's called a constraint, which can be represented. If I did put a number here like a 3, that would represent a constraint, but the implementation details then are a little bit more complicated. We can talk about that when we get to the implementation. Something else to consider with relationships. So we have to think about not just whether it's a 1-to-many relationship and how that connects up, but there's also this concept of participation, meaning do these entities have to participate in this relationship, right? So if I'm an employee, do I have to have a dependent? No, I don't. But if I'm a dependent, do I have to have an employee associated with me? Yes, absolutely, I do, right? And so we can indicate, sorry, this is just bothering me the way that it's drawn. We can indicate participation. How do we indicate participation? Isn't it just a double line? I think it's just a double line. Let me look that up because I don't want to get it wrong. Help me out, Google. ER diagram, relationship, participation. I skipped an important step. Cool, I'm glad I did this because I was barking up the wrong tree for a second. All right, cool. No shame in Googling stuff, guys. No shame at all. I'm not ashamed. I'm generally not ashamed of many things anyway, but I'm definitely not ashamed of that. Right? I skipped a step. It's not enough to define the 1-to-many relationship, but traditionally on a diagram, we're going to include a box here that describes what that relationship is. That was the step that I skipped. So in this case, an employee is, how would I describe that relationship? An employee is responsible for, right, their dependents. So that's a really long word to put in this tiny box. Responsible for these dependents. I know this is small. We'll do more examples of this. And now I can draw the participation, right? If the dependent has to have an employee associated with it, this would be a double line, and I can try and make this a little more clear. Right? It'd be a double line. But if an employee does not have to have a dependent, this would be a single line, indicating that participation on the employee's side is optional. Participation is not required on the employee's side. We started off with kind of a doozy of a relationship there. They're not all going to be this tricky to talk about conceptually. Let's try at least a few more until we get the hang of this, right? What's another relationship? What are some other entities that we think should be related in this diagram? What do we think? Yeah.
Employee has a department.
Employee has a department, right? So how would I describe that relationship? What would I put inside the box here? Let's say an employee works for a department, right? That could work. Or a department supervises employees. I'm not sure. I think either one would be acceptable, right? Works for. Now I have to decide on what kind of relationship it is. So just say it out in English. One employee can work for many departments. Is that true? Actually, I think the answer to that question could be yes or it could be no. It depends on where you're at, right? Depends on where you're at.
The department has many employees.
And then one department has many employees. How do we feel about that? That one I feel like is a pretty safe one to say for sure, right? One department has many employees, but the other one depends on where you're at. Depends on what you're doing. I can speak from experience. I've worked for multiple departments here at WashU. It happens, right? So, this could be another example of a many-to-many relationship. Or if you really feel strongly about it, it could be an example of a one-to-many relationship. I would be okay with that as long as you're prepared to justify that type of relationship. And then we have to answer the question of participation. Does a department have to have employees? It's a weird question, right?
No.
It's a weird question. I think the answer is no. I think you could make an argument for no. I don't like talking in absolutes, especially when it comes to design. That's a trap. I think the answer could be no. I think the answer could be no. I think the answer could also potentially be yes. Could also potentially be yes. What about the opposite? Does an employee have to have a department associated with them? Have you guys seen that show on HBO where they send what's his name off to what is it called? Silicon Valley? Yeah. What's his face? Makes the CEO mad or whatever, but they can't fire him, so they send him off to the roof and he just hangs out grilling burgers all day, getting paid for it. Right? What I'm trying to say is, right, that maybe you don't have an apartment associate. Maybe you're just kind of floating around. Does our chancellor work for a department? The chancellor's office. Right? These are the kinds of questions you can ask to try and help you figure these things out, right? Does the CEO of Google work for a department? He does whatever he wants, right? These are the kinds of things you can ask to try and help you answer these questions. So, for the sake of this example, what's our answer? I think I'm going to say employee has to have a department, but a department maybe doesn't have to have employees associated with it. If you disagree with me, cool. Make your own design. I'm not going to stop you. Do what you think is right. That's what design is about. Let's do, how are we doing on time? Okay, let's do one more. Let's do one more relationship. What's another? There's more than one relationship left up here, but let's do one more relationship before we move on to the next thing. What's another relationship you guys see up here? Yeah.
Employees and projects.
Employees and projects. All right, cool. Might help to refer back to the spec maybe on this one too. So here's actually an interesting piece. An employee can work for one department, but may have many projects. So that actually changes our implementation, doesn't it? Is it a many-to-many anymore? Based on that spec, it's saying one employee can only work for one department, right? So what side does that change? This actually becomes a one-to-many. This is what happens when you don't read your requirements, right? Software engineering 101. Read your requirements. Make your design match the requirements. The requirements right here says each employee can work for one department. So it's actually a one-to-many here. It's actually a one-to-many. That word can also maybe suggests that this participation is somewhat optional as well, right? All right, sorry. Employees and projects. So it says an employee can have many projects. Okay, so an employee, here's our diamond. How do we describe this? Works on, right? Works on projects. And again, we have to decide, okay, the spec here kind of helps us, right? One employee can work on many projects. One project can have many employees associated with it. Yeah, sure, absolutely. And then participation. Does a project have to have an employee? I think you could argue that it doesn't. Does an employee have to have a project? I think that one's a much safer no, does not have to have a project. So the participation here could be optional on both sides. I'd be okay with that. Be all right with that. Cool. Any questions about what we've done so far? Got a couple kind of loose ends to tie up, and then we'll move on to our next topic. One loose end to tie up is that sometimes an entity can relate to itself. There's actually an example that we could do here. Can anybody think about what that is? It's tricky. Yeah.
Projects could be subprojects of other projects.
Projects could be subprojects of other projects. I don't disagree with you. I think it's easier to see with a different entity, though, like this guy. Employees can manage other employees who can manage other employees, right? Manage other employees. So there's a relationship there as well. We call that a recursive relationship, where an entity relates to itself. That's definitely possible. And you run through the same steps. Draw your box. In this case, the box would say manages. Decide whether it's a one-to-many relationship, many-to-many relationship, right? Sketch the relationship out just like you would normally. The other thing to consider is that in a case of a many-to-many relationship, like this one or this one, and technically for one-to-many relationships as well, but we don't see it nearly as often, I can assign attributes to the relationship. And this might be useful for me to do. For example, if I'm looking at projects, right? Employees and projects. An attribute here might be join date. That's too low, you guys maybe can't see. Let me move it up. Join, right? So what is the date that this employee joins this project? It's not an attribute that makes sense based on an employee. It's not an attribute that makes sense based on a project. It's an attribute that makes sense based on the relationship between employees and projects. Right? It needs both sides in order to make sense, to get the full picture. So once you've defined your relationships, you actually kind of maybe want to take a half step backwards and think about, should these relationships have any attributes associated with themselves? Especially the many-to-many relationships. All right. Any questions before we move on to our next? Yes?
Where would those attributes be stored?
Yeah, great question. So we haven't actually talked about implementation yet, but it is on my list, I believe. Yeah. Way down. So if you don't mind, I'm going to pause on that for a second. We're going to talk about normalization, and then hopefully I will answer your question. Great question, though. Any other questions? we're done with our diagram for now. I do want to make it clear that in an ideal world, when I wasn't restricted by the bounds of this small chalkboard, I would have both of these kind of, combined together in one big diagram. We have a name for this. It's called an ER diagram, where E stands for entity and the R stands for relationship, which is the two main components. I've got entities, I've got relationships. ER diagram. So part of the design process, or the big part of the design process, is coming up with an ER diagram. Before we talk about implementation, let's take a little detour and talk about normalization. So the goal of normalization is to reduce data redundancy. Meaning that if I have a piece of information in my database, I want it to be stored in exactly one place, and one place only. Why? Why is that so important? Why is data redundancy considered bad? Yeah.
So you don't have to update multiple entries.
Yeah, if it changes, then if I have it in multiple spots, then when it changes, I have to update all the spots. Or even worse, if I forget, right? Now I've got two different versions of the truth going on, and that could cause some really weird problems down the road. So data redundancy, as far as databases go, is considered to be a bad thing. And normalization is the tool that we use to get rid of it. Now, there are 7 forms of normalization, but in practice, we usually only use 3. I'll speak very briefly about the other forms above 3 at the end a little bit. The good news is that, listen, let me be upfront with you guys. This topic is a little bit confusing and tends to scare people. But the good news is that if you go through the design process, right, chances are your design is already going to be pretty normalized. So you're not going to have to go through the 3 different steps. You can just do a quick verification, right, and you're done. But I'm going to show you what the 3 forms are, because sometimes you're going to run into a database that somebody else made, right, not you, but somebody else made, that is just a hot mess, not normalized at all, and so it is still valuable to know what normalization looks like and how you can apply these 3 forms of normalization to an unnormalized database to try and eliminate data redundancies. So first normal form says that the value stored at the intersection of each row and column, call that a cell, right? The value stored at each cell must be scalar, meaning that I can't try and cram a whole bunch of stuff into one cell. It should represent one single unit of data. And so sort of another part of first normal form is that a table cannot contain any repeating columns. Now this is only first normal form. We've got 3 of them, so this is not going to eliminate all the redundancies, but it will eliminate some. It's a step in the right direction. So let's take a look at an example. Up top here, we have an example of a table that is not in first normal form. And the reason I say that is because of which column? Which column's bothering me here? Item description is the problem because it's got, if I look at that first row, it's got 3 things in it listed out. It's got 3 things in it. The second one has 2 things in it, right? Those are not scalar. Those are not scalar values. That's what I mean by a scalar value, just a single value in that cell. And so one way that you might try to solve this problem is to, all right, let's just split it off into more columns. One item description column isn't enough. I'll make a bunch of item description columns, and then I'll solve my problem, right? Maybe temporarily, but then I'm going to come by later and give you, something that needs 4 items. And so you'll add a new column, and then I'll give you something that needs 10 items, and then you'll add a bunch of more columns, and it just never stops, right? It just or if it does stop, you've got 100 columns, and it looks terrible. It's a mess. So this can be a good first step, but is not normalized, not fully normalized. So with the redundant columns, the better way to do it is to get rid of those redundant columns and instead notice that we've got redundant data here. I don't have repeated columns, but in order to satisfy a single item description column, what I've had to do is copy the vendor name 3 times, whereas before it only appeared once. So now my information is becoming redundant. We're going to fix that. We're going to fix that with steps 2 and 3. But for step 1, I want to make sure every cell has a single piece of data in it, and there are no duplicate columns. This is the easiest step typically to do. Second normal form and third normal form is where things get to be a little bit confusing. So I've got the traditional definition of second normal form up here, but I'm going to try and describe it in a way that's a little bit easier to understand than the traditional definition. It says every non-key column must depend on the entire primary key. And so when I say entire primary key, that's where things start to get a little bit confusing. Second normal form is really only easy to see if you have a table with what's called a composite key, where a composite key is a primary key that takes up more than one column. I know this is a new concept. We haven't talked about this yet. We're actually going to see composite keys pop up all the time. But in order to understand second normal form, we first have to understand this concept of a composite key. So I've got a primary key that consists of more than one column. And then what second normal form is saying that the data in my table must depend on all of the columns of the composite key, not just one column or the other. Let me show you an example that will hopefully make it a little bit more clear. So in this example, I have a composite key. There's a composite primary key. It's not immediately obvious. Can anybody see what my composite key is? What two columns make up the key, the primary key in this table? It's going to be invoice ID and the invoice sequence are going to be the two columns that make up my composite primary key in this table. So with that in mind, right, if I look at a value in any of the other three columns, what second normal form says is that I should be able to uniquely identify all of those values based on the entire primary key. And if I can't do that, I've violated second normal form. So in other words, if I look at the item description column over here, right, every single combination of these two composite key columns uniquely identifies one of these values. I don't see any repeats for a given value. But the same is not true for vendor name, for example, or invoice number. If I want to uniquely identify a row that's got, or this vendor name in it, right, it really has a bunch of different ways that I could pull it out. I can't just give you one combination of invoice ID and invoice sequence to pull out this vendor name. I could give you 1, 1, I could give you 2, 2, I could give you 3, 3, and those all point to the same vendor name, which tells me that vendor name does not depend on the entire primary key, or any of it really for that matter. The same is true for invoice number and for, So these two columns here really violate second normal form. Now, if you are a little confused by what I just said, let me paint the bigger picture here for you. A violation of second normal form means that I've got two entities crammed in the same table. Typically, I want one entity to have its own separate table. So if I'm violating second normal form, that means I've got two entities crammed in the same table. That's usually something that's pretty easy for people to spot. And in this particular example, it's true. We've got two entities crammed in the same table. Does anybody know what the entities are? Look at the repeating things. That gives you a step in the right direction. So one of the entities is an invoice, I think, because I see invoice showing up all over the place, right? You could argue that vendor is the other entity, I think, in this particular example. Or actually, invoice sequence. So if I think about the line items on an invoice, if I'm tracking each individual item, each individual product, you might consider that to be the second entity in this particular case. But regardless, if I want to update my design to follow second normal form, that means splitting the table and drawing a relationship between the two tables that I now have. And so the result would look something like this, where I've got an invoice table up top And this table down here at the bottom would probably be referred to as a line items table, where it represents a single entry on an invoice, right? So an invoice can have multiple items. This is going to represent the individual items, and the table up top is going to represent the invoice as a whole. And notice that now we've got the case where I lost my train of thought there. We've got a relationship on these two tables where the invoice ID value is placed in the line items table to indicate that there's a connection between those two. We're going to talk about that more in just a little bit. So second normal form, I feel like, is the trickiest of the three to understand. Hopefully I did an okay job of getting you there, but if I didn't, or you got lost somewhere along the way, I'd be happy to answer any questions you have about it. Third normal form, yeah, question.
When we use the invoice number as like 1 to 2 instead of invoice ID and invoice, it feels like invoice number is doing the same job as invoice ID.
I think why we can't use invoice number here is because that in practical terms, if I have multiple vendors, there's nothing that says two vendors couldn't use the same invoice ID, right?
So invoice ID is like your internal.
Invoice ID is an internal, yeah, in fact, this is an example of when we look at an entity, we decide that nothing's suitable for the primary key, nothing's suitable, so we just make up our own. We call that a surrogate key. And anytime you see a primary key that's just 1, 2, 3, 4, 5 as a surrogate key, in fact, it's become so common that you're going to see that happen with a large majority of your tables, in fact. Great question. All right, any other questions? Or do third normal form? So third normal form is similar to second normal form, except we don't have to worry about the composite key stuff anymore. Really, it just says each non-key column must depend only on the primary key. So there's no composite key involved, right? It's a little bit easier to kind of formulate this in your head. This example here actually violates third normal form still. I can see that, for example, vendor name does not depend on the primary key because I can't give you one primary key that tells you vendor name. Or if I tell you a vendor name, I can't say which primary key corresponds to that vendor name. There's more than one primary key in this example that corresponds to this particular vendor. So that example violates third normal form, and it's actually sort of the same idea as second normal form. If I see a violation of third normal form, that typically means that I've got multiple entities in the same table, or perhaps I've got a column that's in the wrong entity. It's just it's a good column. It's just in the wrong table. It's in the wrong spot. And so these are actually the same two tables as before, but just with a lot more entities involved. And you can see that once we list the entities out, it's pretty clear to me that there should be some kind of a vendor table involved, right? I see a whole bunch. I see vendor popping up a whole lot here. And that's a classic example of a violation of third normal form. I have a table called one thing, but inside of that table, I see a whole bunch of columns that are referring to something else, some other kind of entity. So vendor really should be its own separate table here. Is kind of the main gist of this slide. I'm running out of time, sorry, so I'm gonna try and get us back up to the speed because there's some important stuff here at the end I want to make sure that I chat with you all about. So here then is what the final diagram might look like. And again, I want to reiterate the fact that if I had sat down and designed this going through the design steps that we did with the ER diagram, I probably would have ended up with something a lot closer to this. It might not be perfect, right? But I probably would have ended up with something pretty close to this already. So going through and applying first normal form, second normal form, third normal form is not usually an exercise that needs to be done in practice. Perfect. Any questions? Any questions? So if you're thinking about this in terms of practical terms, in terms of this course, right? Am I going to ask you to apply first normal form, second normal form, third normal form? Probably not outside of small examples like this, right? I'm actually more interested in, can you design a good ER diagram? Can you show me what the entities are? Can you show me what the attributes are? Can you explain to me why this is in third normal form? That's a question that I'm interested in, more so than actually applying the three forms to the diagram. And earlier I mentioned there are 7 forms, so if you imagine this diagram now, 7th normal form actually kind of goes a little bit to the extreme and would include a lot smaller tables with a lot more relationships than what you see. Excuse me. Up here. All right. Implementation. So we've got our design. I want to turn it into an actual database. There's some information here that's missing. One thing in particular, actually, especially if we look at this one, right? There's some important information that's missing from our design that I would need to know if I want to make an implementation of it. Like what? Yeah. Yeah.
Types of the different
data types. That's the big thing that's missing. As far as design goes, doesn't care about data types. Your design is just interested in the structure of your data, the entities and the relationships. Doesn't care about data types, but the implementation cares very much about data types. And so often what I would do is I'd take this entity diagram and actually go back through and start labeling stuff with the data types that I expect, which in some cases would be very straightforward. In other cases might require a little bit of thought, right? Might require a little bit of thinking about what you want to do. So, street is a pretty obvious care or varchar, depending on which one you prefer. But remember, with string types, I also have to provide a maximum length, right? So, I don't know. Always gets bigger than what you think. Think about the biggest one that you need to, and then add 20 to it, because you never really know what's going to happen. So I do that with all my attributes. I go through and I add data types. And then once I've got my data types added, it's a nice transition from my ER diagram to my implementation. The entities become tables. The entities become tables. The attributes become columns in those tables. The values that I've underlined here are going to become the primary key. If I've underlined multiple if I underline multiple attributes, then I just pick one, right? Pick one to be my primary key. Whatever I need to do. Where things get a little bit confusing are when we talk about relationships. So in order for a relationship to be expressed in our implementation, I have to define that relationship between two tables. And the way that we do that is what's called a primary key, foreign key relationship. So the example that we saw actually a few slides ago can help illustrate this. Every one of these invoice line items belongs to an invoice. And I want to keep track of what invoice it belongs to. And so over here you notice I have an invoice ID column that is actually pointing back to my invoices table. So in the invoices table, this invoice ID column is what we call the primary key. It uniquely identifies every invoice in the table. In this invoice line items table, the invoice ID is what I would call a foreign key. It is a pointer back to the invoices table. And unlike the primary key side, you'll notice that the foreign key does not uniquely identify a row. It can show up many times. In fact, you can see the illustration here of a one-to-many relationship, right? The primary key of 1 shows up here once, but can appear many times in this side of the relationship, right? One to many. So the foreign key can often appear multiple times. Where things get a little trickier still, in terms of implementation, are many-to-many relationships. Many-to-many relationships. That requires an additional structure for us to implement this many-to-many relationship, an additional table that we call a linking table, which is why I've been very, very careful, right? up until now. Entities and tables are not the same thing. They're not equivalent. Entities are usually represented by tables in our database, but they're not the only things that are represented by tables in our database. One classic example is a linking table. It's not an entity. It's actually helping us define a relationship. So if I think about what a linking table for this relationship might look like between employees and projects, can I use this board over here maybe? Notice that it's a many-to-many relationship between employees and projects, and so I'm going to have a column for employees, which is going to be the employee number, right? I'm going to have another column for projects, the project number. These columns are what? How would I describe this column? Ends, yes, we actually have a name we just talked about. Rhymes with, I don't know, boring fee? Yeah, there we go, cool. I know. They're foreign keys. They're foreign keys, pointing to the tables that are being related, right, to each other. They're foreign keys. Okay? So I've got foreign keys for each of the two entities that I'm relating, and then any other columns that I need are just any other attributes. I was talking about this before, right? How I can define attributes for a relationship. So for a many-to-many relationship, not uncommon to see attributes. So any attributes will also get their columns here, right? And then if I look at this table, this means that employee number 1 works on project 2, and employee number 1 also works on project 3, right? And so I can see the many-to-many relationship there. Or project 3, also has employee 2 associated with it, right? So I can see the many-to-many relationship in this linking table. That's how many-to-many relationships are implemented in practice. Are there any questions about that? Yeah.
So would you create like an arbitrary primary key for that table, or would you?
Great question. What is the primary key for this table? Does anybody know? So here's a question that's might help us answer that question, maybe not. Do I need a primary key? I know you know, because you just asked me about this earlier today. We don't. Technically, do not need a primary key. Not strictly required, but it's pretty rare to not see a primary key on a table. So in this case, there is a good candidate for a primary key. In fact, it uses the concept that we just talked about during second normal form. Having a composite key based off of these two columns, the foreign key columns. And so if you're going to see a primary key in a linking table, that's usually what it is. Composite key based on the foreign key columns. Because I don't expect these to show up more than once, right? This combination, I don't expect to show up more than once. Does that make sense to everybody? Does anybody have any questions about that? Yeah.
Is a linking table something that we get for free when we do connections between two tables, or is that something we automatically have to put in?
No, you have to create the linking table if you need it. Now, if this is what really I think is the distinction between the two types of relationships we've been talking about, though, in terms of the implementation of them. If I'm making a one-to-many relationship, I don't need this. And most of the relationships that we see are going to be one-to-many relationships. So, if you've made it this far in life and you haven't seen a linking table yet, that doesn't surprise me at all, right? They're not rare, but they're not super common either. It's only when I have a many-to-many relationship that I have to think about making a linking table. And this is a classic example of a many-to-many relationship, some sort of membership, right? Some sort of group membership, project membership. Classic many-to-many linking table example. How are we doing on time? Oh, good. We're doing great on time. Any other questions? Great questions. All right. And so then to wrap up our implementation piece, let's just quickly, with the 5 minutes we got left, go through a little bit of the SQL involved with creating these things. So in order to create tables, I first need to have a database. So that's a very simple query that you can execute and run. create database and then give it a name. It's when we create tables that things get to be a little bit more complicated. So here's an example of a create table statement, and when I create a table, I have to specify the columns and the types of the columns, and then I also need to somehow specify primary keys and foreign keys, which is actually not done in this particular example. Actually, here's an example of a table that does not really have a good candidate for a primary key, right, necessarily. So there are some options that you can consider adding to columns as you are putting together your create table statement, such as, do I want to allow null values to appear in this column or not? So do I want this data to be optional or not? In some cases, I think you could see how that would be perfectly okay, right? In other cases, I think you could see how, if I'm tracking employees, I probably don't want their name column to be null, right? That's probably not going to be allowed. Once I've created my tables, well, we'll talk more about relationships on Wednesday. So when it comes to creating primary key, foreign key relationships, I'll show you the SQL for that on Wednesday. But once I've got tables, I can then start inserting data into the tables. So here is a true story of my cat. When I adopted him, his name was Seth. And so if I wanted to indicate that into this little example here, I can write this insertion statement, insert into the table name that I want, and then you'll notice here I'm using the verbose syntax for insertion, where I'm listing the name of every column. If I am specifying every single column here, which in this case I believe I am, I don't need to list the names of all the columns. I can leave that part out and just put the values. If I only know some of the values and I'm leaving some of the other values blank, then I do need to specify which columns I'm setting and what order I'm setting them in. But anyway, in this case, you can see, inserting a row into the pet table for my pet cat. I thought Seth was a terrible name for a cat. Maybe you don't agree with me. You're wrong, but you're entitled to your opinion. So I changed his name to Franklin, and if I wanted to reflect that name change in our database, I would issue what's called an update statement. So I'm going to update the pet table. I'm setting the name to be Franklin where the name used to be Seth. Now we need to be a little bit careful with this statement, right? In this example, it works because it's such a small example, but if anybody else had a cat or a dog or whatever named Seth, it would also get changed to Franklin, which is probably not what I intended to do. So we have to be a little bit careful about this where criteria. It will match every instance, not just the first one that it finds. Another thing to consider here is the order of operations. You can see I've written this query. It's got 3 lines to it, right? But which line actually happens first? Of the 3. Actually, it's the first one. I tricked you. But which line happens second? The where, yeah. The first one has to be first, right? Because I need to know which table I'm grabbing the data from. That one happens first, then the where, and then the set. This is our first, but not our last example of things not operating from top to bottom in a SQL query. We're going to see this and talk about this a lot more in the coming weeks. And then last, but certainly not least, if I want to delete a row from a table, it looks very similar to update, delete from table name, where the name or some criteria, right, for what you want to delete. But this suffers the same problem that my update statement did. It's going to remove all animals that have the name of Franklin in it, not just mine. So you need to be careful. And another thing to be careful about too is if I remove this clause entirely, it's just going to delete everything from that table. So always, 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 always want a where clause with a delete statement. You only have to make that mistake once before you get that drilled into your brain. And speaking of, now that we've gotten through this, I've posted a second studio to Canvas. Remember, studios are not graded. They're simply supplemental work for you to get experience playing around with databases. So if you did Studio One and you want to keep getting some experience messing around with databases, I ask you to go through a design exercise and implement your design using the SQL that we saw here. So take a look at Studio 2. Be happy to answer any questions you have about that in office hours or otherwise. I guess that's my time. So have a good week, everybody. I'll see you back here on Wednesday.